Here's your lesson on finding side lengths using trigonometry. So when I'm given an angle and one of the sides, and I want to find another side, we need to use trigonometry to find that side. So we're going to circle the angle and identify and label that x is the opposite of that angle, and that 19 is the longest side, which we call the hypotenuse. Then we're going to write down SO, CA, TOA. Those are our definitions of sine, cosine, and tangent. Which one of these three uses opposite and hypotenuse? So we circle that, and then we write down sine of 28 degrees is equal to, opposite goes in the numerator, and the hypotenuse goes in the denominator. And then I solve that and use my calculator. So the opposite of dividing, we're going to multiply both sides by 19. These divide out. Now x is by itself. We're going to use our calculator to solve for x. So just type that in your calculator. So 19 sine 28. Just like that. And the answer is 8.9. All right, let's try the next one. We'll go through the steps again. So we're going to circle the angle. X is the opposite, and 32 is the adjacent of that angle. And we write down SO, CA, TOA. Okay, which one uses opposite and adjacent? O and A. So that's the last one. So we're going to write down tangent of that angle is equal to opposite, which is x, over adjacent, which is 32. Then we're going to multiply by 32 and then use our calculator. So again, 32 tangent 41, and you get 27.8 with your calculator. Number 6. Let's go through the steps again. Circle the angle. X is adjacent, and 26 is the hypotenuse. So, CA, TOA, which of these trig ratios uses adjacent and hypotenuse? And then we write down cosine of the angle, 21, is equal to, the numerator is the adjacent side, which is x. The denominator is the hypotenuse, which is 26. And then multiply by 26 to get x by itself. And this is what you're going to put in the calculator. 26 cosine 21. So know in your calculator where your trig buttons are here in the middle. So again, we're going to press 26, then cosine, so that middle button cosine, and then 21. 24.3. Number 7. Circle the angle. 8 is adjacent, x is opposite, SO, CA, TOA. Circle the one that we're going to use, O and A. That's tangent of 55 is equal to opposite over adjacent. And then solve for x. So we're going to multiply by 8 and then use your calculator. You get 11.4. Number 8. Circle the angle, opposite, and hypotenuse. So I don't need to go further than that. Opposite and hypotenuse, that's sine. So we write down sine of the angle 33. The numerator is the opposite, and then the hypotenuse is x. To solve this, to make it simple, since x is in the denominator, sine 33 and x will change positions to make it easy to solve. So it's going to be x equals 15 over sine 33, and then use your calculator. So in one, you're going to divide, and in the other, you're going to multiply. So for this one, we're going to divide. So 15 divided by, again, press the sine button, and 33. And that missing side is 27.5. Number 9, circle the angle. That's adjacent, and this is hypotenuse. So, ka, that's all I have to write down, so I know it's adjacent over hypotenuse. So it's cosine 43 is equal to adjacent over the hypotenuse. Because x is in the denominator, these are going to trade positions to solve it, and then use your calculator. So it's 36 divided by cosine 43. 49.2. Number 10. That's again using trigonometry. Circle the angle. X is adjacent and 25 is opposite of 72. So, ka, toa. We need to go all the way across. Which one uses opposite and adjacent? So we're going to write down the tangent of 72 is equal to 25 over x. We're going to trade positions here. So dividing 25 divided by tangent 72. And then put that in our calculator. 25 divided by tangent 72. And you get the answer 8.1. The setup. Circle the angle. X is adjacent and 11 is the hypotenuse. So, ka, that's where I can stop. It's adjacent and a hypotenuse. So it's cosine. So we write down cosine of 64. The adjacent over the hypotenuse. Here, x is in the numerator. So we're going to multiply by 11. And then instead of divide, so it's 11 times cosine 64, and I get 4.8. All right, let's do some stories connected to trigonometry. Jake leaned a 12-foot ladder against the house. The angle formed the ladder and the ground is 68. How far from the base of the house did he place the ladder? So I'm going to draw a house. And I'm going to draw a ladder leaning against that house. And the ground where the ladder and the house is, right there. And I want you to see a right triangle right here with the ladder and the house. 12 feet is the ladder, that's the hypotenuse. And this angle here, the ladder and the ground, is 68 degrees, that angle. And what we're looking for is how far from the base of the house did he place the ladder. So this bottom part here is what I'm looking for. So if this is 68 degrees, this is adjacent over hypotenuse. So we're going to write down cosine 68 adjacent over hypotenuse. Multiply by 12 and then use your calculator. And you get 4.5. So how far from the base of the house did he place the ladder? And the answer is 4.5 feet. Number 13. A ramp is used to load suitcases on an airplane if the cargo door is 7 feet from the ground and the angle formed from the end of the ramp and the ground is 25 degrees. How long is the ramp? So a ramp is just a right triangle, right? So there's my ramp. This is what I'm looking for, how long the ramp is. And it says the height of the ramp is 7. And this angle the ramp makes is 25 degrees. And up here somewhere is the plane where the suitcases go on. How do I solve for how long that ramp is? Circle the angle. That's opposite and hypotenuse. So we're going to write down sine is opposite and hypotenuse. So sine 25 is equal to 7 over x. And then we're going to trade places and use our calculator. So it's going to be 7 divided by sine 25. And the ramp is 16.6 feet long. And you have your answer. So there's your lesson on finding lengths. Now you can do the practice sheet that was handed to you. And there's another video to help you support you through that. Mr. DeMatt, over now.